very excited to present what's new in Nextflow. It's a new version of Nextflow. As Eva mentioned this morning, we are committed to deliver better software to enable better science. And for us, this means essentially continue to evolve Nextflow, that is transforming from an open source technology, a single tool, to an ecosystem of technology in which there are different components, each of them dedicated to solve some specific problem when it comes to deploy the scale computational pipeline into the cloud, but not only the cloud, also in an infrastructure. So we have Nextflow for orchestration of the pipeline, way for continuous provisioning, multi-QC for visualization, Fusion for managing the storage in optimal manner, and the Seqera platform, that is the platform where we keep all this stack together and also provide other features. Into this presentation, I will focus on three main components: Fusion, Wave, and Nextflow. So let's start with Fusion. So why we need a specialized file system for Nextflow data pipelines, or data pipelines in general? Because the real bottleneck into this pipeline, the real problem is not to scale the compute. You can have plenty of compute on demand, but the real problem is to use in an optimal manner the storage, because this pipeline consumes a lot of data, produce a lot of data. So if you don't have an optimal strategy to manage data transfer into the data pipeline, you just burn the money. There are plenty of different solutions out there, but most of the time they are implementation that came from legacy distributed system, mostly designed for HPC. So most of the time they can work in the cloud, but they are very expensive. They tend to have fixed allocation, so you can have problem when running out of space. And then it's an extra service that you need to maintain, etc. So instead, the ideal solution would be to have something that is the object storage, because the object storage is the native storage for the cloud. It's relatively cheap and is scaled very well. But the problem is that there is a mismatch between the tools that we use in our pipeline. They use just files to access and share the data with the object storage that use an HTTP interface. And this is where it came Fusion, that ultimately is an after layer that make it possible to use the object storage like a local file system or a distributed file system. What is important is to highlight is that there are other solutions similar to Fusion. At the end, we implemented this like a Fuse driver, Linux Fuse driver. But the real point is that we designed and implemented this solution taking in mind the model how Nextflow works. So we managed to optimize for Nextflow pipeline and the way how Nextflow organizes the data into your pipeline. And above all, also a very important key point into this technology that was designed to handle large data that is typical into these data pipelines. And instead, that is not common. We using common tools or general purpose Fuse driver. There are several capabilities on this technology. Is able to prefetch all the data while the pipeline is running, the task is running, and also upload in a synchronous manner all the data while the job is running, and also supports bullet links over the object storage. And above all, it's super easy to install. You don't have almost anything to configure into your pipeline. It's completely transparent and opt-in solution for your Nextflow pipeline. And this is a quick chart that represents more or less the architecture of this technology. Essentially, when Nextflow run and launch the execution jobs into the cloud, the job run into the container, and we deliver the Fusion driver within the container. So compared to other solutions, this is not need to be installed, the compute host, but is shipped along with the job and running in the same container. And then this created the adaptation layer. It is the adapter layer between the job, the access, the bucket, like if the bucket is a local file system. But behind the scene, here, the nice thing is that in practical terms, what we are doing, what this technology does, is using the local scratch disk as a temporary cache. This is why it managed to be so fast, because at the end of the day, what is happening, the job in reality is working with a local scratch disk and then synchronize all the data automatically with the bucket. This is the main idea of this technology. So key benefit of Fusion is faster compared to general purpose tools or other open source implementation. Fuse driver for object storage is comparable in efficiency and in performance like distributed file system like Lustre, but at the same time it's cheaper because you don't have to pay for an extra service. So there is this benefit. And also the other key benefit is that you don't run out of space. This is very common when we run computational pipelines, life science pipeline into the cloud, that you are limited by the local disk because we need to copy all the data into the VM, but it's very easy to run out of space, so you need to allocate very large disk, etc. Instead, Fusion is able to use the in a dynamic manner, so prevent that you run out of space when you run the large task into your compute nodes in the cloud. Also, an important point that is all the I/O pressure into the Nextflow driver job. So this is important. When we run Nextflow, we have the data into S3, and we use as a work directory, maybe a shared file system. Essentially, Nextflow needs to copy all the data from the bucket in the shared file system, compute the task, and copy back the result eventually into the bucket. So all this data transfer need to be managed by the Nextflow driver application. So this creates a serious bottleneck, make it difficult to scale the application. So when we use Fusion, we delegate to this system all the data transfer. So this is also another benefit using this technology. So what's new in Fusion 2.3? We released the past week. We focus on stability, interoperability across cloud provider. Now it's production ready across all 3 major cloud providers. So Amazon S3, Google Storage, and Azure Blob Storage. You can use this technology both with Seqera platform and then Nextflow command line. Here there is a benchmark that we made to validate the benefit using this technology, running a pipeline, consuming and producing large file. Each task was producing 100 gigabyte, and to show the benefit using Fusion compared the standard, the classic way Nextflow to use to operate, to copy the data into the compute job. Here on Amazon and Fusion compare the classic Nextflow execution over AWS batch S3. In this case, Nextflow would use this AWS S3 command line to copy the data into the node, compute, and then copy back the result. Essentially, using Fusion is 1.7 times faster, so there is a quite interesting benefit. And very similar also when using the same pipeline on Google Batch and Google Storage. Also, we have 1.6 speed up compared to the default implementation, in which Nextflow instead used GCS Fuse, a similar another Fuse driver, an open source Fuse driver for Google. With Azure, quite interesting. Basically, the performance are very similar. Here, what can be interesting to note is that it's not Fusion that cannot improve the performance. That is, Azure is quite good to work in optimal manner also with the default implementation on Nextflow that use the add-zip copy command line tool. We think because as bit faster network and also local disk, the VM into the Azure cloud. In any case, we continue to work on this technology. We learn a lot of stuff working with Fusion, and we have still some idea how we can still improve the efficiency of the Fusion when working with object storage and data pipelines. One area in which we are working right now to implement the capability to use another layer of caching. So far, Fusion used the local scratch disk to speed up the operation, and what we are doing right now is that to use the available memory into the container to have another layer of buffering to speed up the I/O. Another area that we are improving, we are working to improve the performance when handling a large number of small files. This is a common headache for many file system. Imagine that you are task producing thousands of small files. You need to, basically, the file system need to manage all the metadata for each of them. And this can create a lot of inefficiency. So we are working also this area, how we can improve. And finally, another point is to make it possible to use this technology, not just with object storage, but with traditional classic file system, shared file system. So with the idea to move and make it possible to use Fusion also with classic shared file system out of the cloud. And okay, this close a bit the part about the storage. We jump instead into the container world. Wave is our service that we created to streamline the provisioning of container, the life cycle of container. Here, the idea that going beyond the classic workflow that we have, that we need to manage the container that consists build the container, that you need to authorize the registry, push the container to the registry, and then pull when you run in your pipeline. So this can be done, but now lifecycle pipeline, F-core pipeline, these applications tend to have a large number of containers. So to maintain all these containers is a lot of work, create a lot of friction, make difficult to deploy at scale. So we want to make this operation more transparent, more easy. And the idea is very simple. We have all the information in the Nextflow task definition about the dependencies of each tool or each task. So we can just use that metadata, the information about the dependency that we declare into Nextflow and the F-core pipeline, or any other pipeline, to deliver on demand the container while the pipeline is running. We don't need to pre-build or maintain manually. And also, using this technology, this approach, we can create containers that fit the requirement of the target architecture. I can create automatically container for Singularity or maybe for Graviton, depending where I run in my pipeline. So this makes much easier to migrate or port my pipeline a different architecture. And this is a representation of the architecture of Wave. We have Nextflow running. Essentially, when Nextflow needs to launch a job, before launching a job, make a query to Wave, specify what are the dependencies that are required by the task execution. And then Wave is able to check if a container already exists with that dependencies, and otherwise, be it provision the container on the fly, and then return back the container to Nextflow that continue execution like any other pipeline. What is important to highlight into this mechanism, we have two main operational modes. One is what we call ephemeral containers that are short-lived containers that essentially are provisioned by Wave, just adding the dependency that are needed by your task. Imagine that your task has some custom script and you want to this run into the container. So in this case, what it's doing, just adding the script to the existing container, not even rebuilding. So this is a pure ephemeral operation that is done while the container is downloaded. So this is not create container, does not copy anything, just modify on the fly the container. Instead, there is a second capability that is instead to create durable container with what we call the freeze mode. So this create container on demand that are hosted, stored in the registry that you specified into Nextflow configuration file. So this essentially build the container on the fly, also where you desire that are stored. And today, like Evan was mentioning this morning, we are introducing a new capability, what we call Seqera container. A Seqera container is essentially a virtual limited container collection for the bioinformatics community that is maintained and generated on demand. So every time that you need a container, this can be assembled with any Conda package or combination of Conda packages and uploaded into a community registry that we are supporting, and we are created with the sponsorship of AWS, Amazon Web Services. So we have community registry that allow us to store permanently all these community images. They can be multi-format, both for Docker Singularity, and multi-platform, so both for Intel and Graviton. And as I mentioned, it is public accessible and can be used by everybody. And this is how does it work, the Seqera container. So essentially we have our Nextflow, the Seqera hub front end allows us to request a container, which we can specify which package, which tool we want to use into this container. These are fetched from the content registry, and then this is delivered on demand using a registry that is hosted by the Amazon cloud. And from there, we can download like any other container. This is quite nice. I want to show in practical terms how does it work. So here we are into the Seqera website. Let's make, oops, a bit bigger. A new section, container. On the left, I have several channels or sources from where I can fetch the packages. For now, we have just Python packages, Bioconda, Conda but we are planning to add more. Let's say that I want to use only Bioconda, Conda, and then I can search the tool that I want to use my container. I can use BWA, and then this is just a search, and then show all the packages that are available. I can decide to use this one, and then I can get the container. So these are popular tools, so it's very easy that you find these tools already pre-built in the cache, so super fast. I can just take the container name. This is also community.wave.seqera.io. This is the name of the tool, the version of the tool, and this is a checksum that represents exactly the let's say the composition of the container. So this makes also more replicable. And then I can use like any other container. I just can key my terminal, and then I can run this container. It was DWA. Here we go. And so to some extent, you may think, but this is basically the same as biocontainers. What's new? It's new that you can decide to use, for example, ARM architecture, and now I can create this container for ARM just clicking this button. This is something that you cannot do with biocontainer, or maybe you can decide to have a Singularity container for Intel. And again, this case is important to notice that this is not a Docker container that is downloaded, converted by Singularity, but this is built with Singularity. Is a Singularity image file that is uploaded to a Docker registry, and from there we can download, if you notice, as this pseudo protocol that is Horas, that is a pseudo protocol used by Singularity to download Singularity image file from an OCI registry. So, like in the other case, I could jump here. I need another VM because this is Singularity. Timeout. Clear Singularity exec, and again BWA. Downloaded Horas image, and this run. And but the nicest part, then I can create container with not just with a single package, but any package that I want to include into my container. So I could use some tools, bound tools, and then again BWA, depending what you want to do, and then you get the container. Oops, here we go. Sympathy. Let's try Docker. Oh la la, it's not working. Let's try bound tools only. Okay, assertive building. Okay, this is supposed to, anyhow, to create a container with multiple images, multiple packages. And this is the overall idea. So provision container on the fly using different packages for different architecture. And how we use this in our pipeline. So here, the point is, with this nice front end, we can provision container very easily, but usually when I want to use my pipeline, you are not supposed to come here to pick this one by one and put into Nextflow configuration file. Instead, what we can do is we can just configure Nextflow to use this container. So let's say that now I want to use this RNSI pipeline. This is a small example pipeline that usually I use for demo. And here, this by default use one single container for all the pipeline execution. You can see with the spec command, you see that use this container that is key.io Nextflow RNSI NF 1.21. But I may want to use now Seqera container, so it's enough that I create the Nextflow config file. And here I can say I want to use wave, enable, true, and then I need to enable freeze mode, true, and then true, and then need to enable the strategy conda. That means that we want provision container using the conda packages into my Nextflow pipeline. This is enough that if I repeat the Nextflow spec command, now I get the Seqera container that came from the community registry. You see they are changed to community with Seqera.io, I have Salmo 110.2, Salmo 110.2, MultiQC 170, etc., and FastQC. And so this allows me to switch easily to different containers. It also can be interesting, what if I want to change to another container? I noticed that maybe field just update MultiQC, I want to use the latest version MultiQC. What I could do, for example, I could clone this pipeline here, and then I go into the modules, MultiQC, there is main. Here, so you will find the conda package. This is using bioconda MultiQC 117. I want to use 21. This is enough. Now, if I repeat the spec command to my local copy, now I should get the new container. So this makes it dramatically easy to keep aligned your pipeline to use new container as they are provided. If this container does not exist, it's built on demand. This is all the point. And you don't need to maintain anything else. And okay, this I think make quite clear how does it work. This mechanism is both has a front end, is integrated into Nextflow, and makes it dramatically easy to use and to update, keep updated the container in your pipeline. And okay, then let's jump into a bit about Nextflow. What's new into Nextflow? This week we just released a new version, 24.04, and there are some new interesting things that is nice to mention. So about container compute, okay, I already talked about Seqera containers are fully integrated. What it can be interesting to mention other to this is that, okay, this technology is fantastic. We can use a public accessible container, but what if you want to use this technology with your own registry? Is enough that you add this configuration. So to the previous configuration, you can specify the repository, your own repository, and when you do that, basically, the container are provisioned, used, stored into your repository. So this will allow you to maintain your own private copy of container without using the public one. And about compute, okay, this morning were mentioned the job array that are interesting capability to scale the computation in several scheduling engine. And finally, there is support for job array into Nextflow, so you don't have to decide anymore or job array or Nextflow. You can use both together. And this basically, when you run a job array with Nextflow, this submit the job, and then the underlying scheduler replicate the job in many different tasks. Each of them has different index, and this allows the scheduler to optimize the execution on this task and scale better. Currently, this capability is supported by HPC batch scheduler that are Solar, LSF, Green Engine, also PBS. And for cloud, we are supporting AWS batch and Google batch. And to enable the use of job array into Nextflow pipeline, essentially what you need to do is just add the array directive, your Nextflow configuration, specifying the size of the array. AWS with Fargate. So Nextflow has support for AWS batch since ages, but always use the classic implementation, which AWS batch launch EC2 instances to run the container at the job in your pipeline via ECS. AWS also the capability to use Fargate, essentially that are managed container that does not need EC2 instances, or at least not directly managed in your infrastructure, but are managed behind the scene by AWS. So these are some cases can have some advantages, because to launch this container, there is less latencies. It's also a bit less complicated to configure, because you don't need a custom AMI when you need to configure Nextflow to use with AWS batch. So there are some benefit. On the other hand, you may lose some control in the configuration environment, because when you use Fargate, you don't have anymore the capability to control the launch template. You have more strict security constraints. So there are some pros and cons that should be taken into consideration. But it's nice to know that also now we have this capability into Nextflow. Also new 30-part executor, we listened before about Memverge. This is a fantastic platform to optimize the computation using their technology. Also Nextflow has now support for Yellow Dog, and older to this, it was just announced that also the support for Risky. So there are different providers. These are extensions not implemented by us, but by the 30-part provider. And I mentioned because I think it's very interesting from the fact that this consolidates essentially the Nextflow mission to provide platform or capability to deploy computational pipeline in a portable manner in different infrastructure. So you have your pipeline can be adapted, very easy to run many different execution backend, and you can choose which is the best one for you. Then about language and DSI, what's new? Few months ago, we added in the edge release a new type of channel into Nextflow pipeline. Historically, Nextflow had two types of channel. That is variable that we use to share the data between tasks. And there was the value channel that essentially is a variable that allows you to only to send one output to many tasks. And then there were the queue channel that allow one task to send many output to another task, so point-to-point communication channel. Now we are in the topic channel that instead is a different pattern in which you have many tasks that can use the same channel to send data to other many tasks. So it's more a broadcast pattern. And this was implemented to solve some specific implementation in some pipeline. It's very common. For example, there was a pattern into an F-core pipeline in which there is this need to have in all tasks collect the version of the tool that has been used, and then they are using always the same channel to send this version across the pipeline execution, then collect into another task. To implement this, there is a lot of redundant code that instead can be dramatically simplified using this new capability. Because this is a quick representation. Basically, you can have many tasks that use the same topic. In this case, we call version, but can be any name. And then all the tasks using the same name, then this channel can be referenced here using channel.topic and collect all the output came from all the tasks. And this simplify this kind of pattern. Along something similar, we have also a new output type that we call eval. And this was also implemented to solve always this common problem that there is an F-core always to collect the metadata, the version of the tool into the task. But in this case, basically the idea is that that we can run when we define the output definition of the task, and one-liner, a small script to collect some metadata. So this is evaluated when the task is complete, and then we use the result of this to script like at the output that is sent out. So to make a bit more clear how to simplify this problem that there is in the NF core pipeline, this is, if you look in the code, in NF core pipeline, there is almost in all tasks at the bottom, this boilerplate. No? And this is made, it is quite complicated to read, but essentially what it's doing is that run this salmon minus version and then create on the fly this file, a YAM file. So this snippet is very annoying because it makes it difficult to understand what is happening in the real task, that maybe it's just this command, then it's also difficult to maintain, to modify, etc. Instead, using the new approach, just to run this, we can use the eval type with the command I want to run, and we can remove all that boilerplate. So make it much more simple and intuitive to maintain. And then another important extension that we finally have into Nextflow is the ability to define the workflow output definition. And so historically, Nextflow managed the output at task level. In each task, there is a directive that is published there, and the published there essentially allows you to copy the output in the path that where you specified. But this was a legacy solution came in from the first iteration Nextflow language. It was not working very well in the SL2 that is all about modularization. So we had this pipeline with a huge configuration to try to keep under control the output path to each task. It was really very difficult to maintain. Instead here is to keep the output definition at central level where the workflow is defined, but also keep at the same time a more flexible way to manage the composition of the structure. So the overall idea is that you have some task. Each task defines a logical name of the output, what we call output target. So each task can have one more target, and the same target can be used by different tasks. So you have to think the target lies the category of the output. And then we can decide where remap or how we can create the corresponding output structure with the real file. So there is a logical representation and a concrete file representation. Also, to make a bit more clear, let's see in practice how does it work. I use always the same pipeline that I was showing you before, RNA-seq models. Let's make a bit. Hola. Okay, here I have four models: FastQC, index, multi-QC, quant. FastQC, there is indeed this declaration, the published here. So this was essentially copying the file produced by the output this task into the path specified this parameter. We don't need this anymore, but what we can do now is to declare a published section where I can define my published target. And to do that, I have to specify the output name, my pipeline in this case, and associate with a target. I can call just whatever I want, but I can call FastQC for simplicity. And this is the logical name of the output coming from this task. I could do the same for multi-QC. Also here I have this published here. And again, I want to use publish. And then here I have this channel, this report, and then I assign report to multi-QC. Also here, just for simplicity. Okay, I define my two targets into this task. The next step is to take the RNA-seq main, the main workflow. I need to enable this feature because it's a preview feature. Preview output. And then the real stuff is essentially adding the output block. The most basic specification implementation can be just specifying the directory, so where I want the output of this pipeline. Let's say results. And this is enough to tell Nextflow to collect all the output produced by my task into this directory. Let's see in practice if I try to run result. I don't have anything. Nextflow run seq with Docker. No, I want to use profile Docker. Okay. So what I'm expecting to find now is a result directory that contains another two directories that are multi-QC and fastQC, because by default the output target are materialized in the concrete path into my file system. Okay, multi-QC, 3 result. Here we go. So we have result, fastQC, and the symbolic link to the fastQC file, and then multi-QC again the symbolic link. So because by default Nextflow creates symbolic link. If you remember, before Nextflow to control the symbolic link or the copy, there was the mode option. And essentially, also here we have more or less the same option also in the output section. So here I can specify copy. If I try to run it again, rf result and this resume, this execute it again, recreate the result, and now I have the concrete file. So what the difference is that now I can control this from a single place. Instead, before I need to modify or use a parameter to control the mode in all the published directive was a bit of a nightmare. And then what else I can do? All the point of this output definition is to control this directory structure. So because this is what it does by default, but maybe I want a complete different structure. I would like to have fastQC in a different path. Maybe I would like to have in the path that is logs. And maybe for fastQC, I would like to use mode symbolic link. So basically I'm telling the target fastQC should go in logs, and in this case I want to use the symbolic link. For all the other, I want the real file. You have to copy the file. Instead, for multi-QC, I want to use a different path, these reverts. Okay, let's try it again. I want to add another profile that is all reads. Okay, add more stuff. Okay, try to resume the task. It is enough to redefine my directory structure or my data in a different way. So I have the capability to remap as I wish all the output my pipeline. Let's see, almost done. 3 result. Okay, you see that now the fastQC file are in logs. They use a symbolic link, and the multi-QC file is in the report directory. So this make it clear how I can remanage, reshape all the output my pipeline as I wish. And the last thing that is nice to mention is that I have also the capability to create index file on demand. So just adding index path, the name of the index file, csv, this basically creates for me while it's generating the output an index file that contains all the file path into that output target. So now I have result, it was logs, index. This is a very basic one, of course, because it's just the file name and the file path. But here this can be much more sophisticated if the output channel was provided in this file was a tuple with some other metadata, and also there is the possibility to have a custom function to customize the content of this index file. So I think this makes it much more flexible how we can manage the output in the Nextflow pipeline. Also allows to create index files. This also allows us to create data structure that are consumable by downstream pipeline execution. And okay, What else? Okay, very, very quickly. Plugin integration, in reality, okay, there was provenance plugin. There was presentation before me, so there is no need to continue to talk about it. And then just quick mention another plugin in which we are working a plugin for GPT. This would require a specific session, but I want just to mention this is essentially allows to integrate to use Nextflow workflow the capability to use OpenAPI API to run GPT query both for textual prompt or data prompt that return structured data. It's quite cool. You try to have a look at this link, and there is also a workflow implemented in Nextflow that essentially allow to optimize prompt using ChatGPT. It's quite interesting, above all for the capability that show how Nextflow can be good also to parallelize AI workflows. So just to summarize, I can give a brief overview of Fusion that enable the scalability of data pipelines and now support all three cloud providers. Wave Container is our technology in the provision container in demand and streamline all the lifecycle of container. And we are introducing Seqera container along with AWS Amazon Web Services, providing an unlimited container for the community, for bioinformatics community to host demand and create demand and create container on demand. Nextflow continue to lead the effort to provide better software for better data pipelines and enable better science. So I hope that you enjoyed this presentation. Thank you.
Thanks, Paolo. We have a lot of questions. I'm going to say a few of them. So is it possible to use the eval process directive with the new topic channel operator at the same time both?
Yeah.
Okay.
So they are independent, but was designed exactly on this idea to use together, actually.
So can Wave also create singularity containers?
Can you repeat?
Can Wave also create singularity containers, like on the background? It's really creating singularity containers?
I don't understand. Sorry.
Singularity?
Yeah.
Okay.
Sure.
So it's real creating.
Yeah.
And is it possible to use Fusion v2 without it being an Nextflow pipeline, like dissociated? Or can they have, for example, a parallel cluster instead of AWS patch?
I didn't get the question. Fusion
so
v2?
Is it possible to use Fusion v2 without Nextflow?
No.
And is it possible to use it with...
Well, technically, yes, but there was a lot of work to streamline within Nextflow, so it's very easy to use with Nextflow. We don't provide outside workflow, but technically, in some extent, it could be possible.
And if someone wants to use Nextflow with Fusion v2 in parallel cluster, is it possible?
Yeah.
Okay. Thank you, Paolo.
Welcome.